Welcome to Ms. Taylor's class notes, and today we're talking about domain and range of quadratic functions. So, I really want you to fill this top half on your own based on what you know about domain and range. We've been talking about domain and range all year long, and so my hope is that you will be able to figure this out. And if not, I'll keep explaining things further down. So, when we talk about domain, we're always going to talk about our x values. How far does it go to the right? How far does it go to the left? And when we talk about all real numbers, we have to have arrows going to both the left and the right. So we're going to be looking for graphs that would have double arrows going both left and right. So if we look at A, we've got arrows going to the left, we've got an arrow going to the right, so our domain is going to be all real numbers. If we look at B, we can graph this real quick in Desmos. Y equals 5x squared. And if we zoom out in Desmos, it's just going to keep going forever and ever and ever, which is our all real numbers. So if we look at this graph here, I do not have an arrow, and if I do not have an arrow, that means I have a point. And so if I have points, my domain cannot be all real numbers. It would go from the furthest to the left is 0, less than or equal to x, and then the furthest to the right that it goes is 1.6. And so that would be my domain of that graph. And again, if we look at D, I got arrows going to the left, I got arrows going to the right, so it's going to be all real numbers. So, is it possible for us to have a quadratic function with a range or a y value, because remember, range is y, of all real numbers? So let's think about all the quadratic functions that we've seen so far. We've got smiley face parabolas that have a vertex, and those are our minimum graphs. We have frowny face parabolas that have the vertex at the top, which are maximum graphs. But if we notice, our graphs always stop at some point, whether it's up or whether it's down. They don't keep going all the way up or all the way down. So no, it will not be possible for us to have a range of all real numbers in quadratics because of the vertex. The vertex is where it stops, and it does not allow it to continue both up and down. So let's look at our domain and range. And again, double arrows to the left and right tells me all real numbers. For quadratics, most of our graphs, it's going to be all real numbers. Now to find our range, we need to think of a couple of different things. We need to know, is this a max or is this a minimum graph? So we need to find that vertex. And so it's a smiley face. So a smiley face is our minimum. And our minimum is always going to be greater than or equal to. So we're going to find that vertex. We're going to find our y value, which is -7. So y is going to be greater than or equal to -7. It's always going to get higher than that point. So again, domain, we're going to check for arrows, and as long as we have 2 arrows, it's going to be all real numbers. And then we're going to find our vertex. So this is a maximum graph. If it's a maximum graph, it's going to be less than or equal to, because it's getting smaller or going down. So it's going to be y is less than or equal to, and then we need to go find our y value of a vertex, which is 3. All right, so how do we do this from equations? If they give us an equation and it's in standard form, our domain is always going to be all real numbers. But how can we find the domain and range by just looking at the graph? So first, we need to look at our a value, because we said in a previous set of notes, if it's a positive a, it's our smiley face. If it's a negative a, it's our frowny face. So a positive a is a minimum, which is greater than or equal to, A negative a is a max, which is less than or equal to. So we find the maximum value by finding the vertex. And then we're going to write our inequality using the maximum or the minimum. So if we remember, we know how to find the x value of our vertex by doing negative b over 2a. And then we can plug that in to find our y value. Again, we said our domain is always going to be all real numbers. So I'm going to plug in my b, which is 10. I'm going to plug in my a, which is 5. And so we get 2 times 5 is 10, negative 10 over 10, which is a negative 1. And that's our x value. So once we get our x value, we plug that x into our equation to find our y. So 5 negative 1 squared plus 10 times negative 1 plus 8. Negative 1 times negative 1 is a positive 1 times 5 is 5. 10 times negative 1 is negative 10 plus 8. So I get a negative 5 plus 8, which should be a positive 3. So once we find that 3, we look at our a value. Our a value is a positive 5. If it's a positive 5, that tells me it's a smiley face. So that means my y is going to be greater than or equal to 3. So I want you to find the domain and range of this one. So go ahead and hit pause, work it on your own. Your range should be y is less than or equal to negative 5. And again, we see that negative 1, which tells us that it should have been a frowny face, which tells us it's less than or equal to. All right, again, I want you to do this one on your own. Pause the video. And you should have gotten y is greater than or equal to negative 9. And again, our domain is still all real numbers. So we haven't looked at a lot of tables, but when we're looking at tables, we can usually find our vertex. So we're looking for where the numbers go from getting bigger to getting smaller. So usually our vertex is going to be that point where we have the same number on either side. So this is going to be our vertex. So I want you to use this information right here, and I want you to find your domain and your range. And then if you real quickly need to graph these points to figure out if it's a maximum or minimum to get the right sign, go ahead and do so. All right, I want you to do this right here. Now remember, if all we have is the range, there's going to be some variation, but there should be one thing that is the same for everybody's graph. All right, and let's real quick go over finding domain and range where we do not have arrows, where instead we have points. So our domain is x value, so we're going to be looking at the x axis. So what's the furthest the graph goes to the left, which is 0, less than or equal to x, and then what's the furthest it goes to the right, less than or equal to 1.5. When we do range, we do y, so we're looking at the y-axis. What's the furthest down it goes, and then what's the highest up that it goes. So we start at 0, less than or equal to y, less than or equal to the highest that it goes is 9. So if we have a bird flying 10 feet above ground, is it going to get hit by the Nerf bullet that launches into the air? And so I want you to answer that one on your own.